So we're going to be looking at this network of genes and skin cells that results in spikes. The S gene promotes the P gene inhibits the I gene or blocks, and the I gene blocks the K gene, and the K gene activates the E gene, which results in spikes. We're going to see if a gene network that is defective in the P gene would result in spikes or not. The S gene activates the P gene just like it normally would, but the P gene is defective so it cannot block the I gene. But the I gene can still block the K gene, and therefore the K cannot activate the E gene. So therefore the spikes are not made if P is defective. This is because the K gene would normally activate the E gene without any interference, but the I gene blocks it, making it so it would not activate the E gene. But P usually blocks I gene. But since P is defective, we don't get any spikes. Now we're looking at a network that's defective in the I gene. The S gene works just fine to promote the P gene, and the P gene works well as well. So it blocks the I gene, but the I gene is defective, so it cannot block the K gene, leaving the K gene to activate the E, which can make spikes. So therefore, there's nothing interfering with the K gene to promote the E gene, which makes spikes. So spikes are made. Now, a network that is defective in both the I gene and the E gene is pretty simple. So the S gene works fine, the P gene works fine, the I gene is blocked, and the K gene works fine. However, the E gene is defective, and the E gene is what makes spikes. So therefore, spikes cannot be made without a working E gene. So looking at a pathway that's defective both in the S and K gene, the S gene cannot activate the P gene, so the P gene would not block the I gene, which I forgot to indicate in this illustration. So therefore, the I gene would block the K gene, but the K gene isn't effective anyways, so the K gene cannot promote or activate the E gene, which just means that spikes aren't made. One reason that spikes might be expressed in one skin cell but not the other is because of histone modification. So let's say that in a cell where the spikes are expressed, maybe the spike genes are in a more accessible place along the histone. So if it's in between histones, then it can be easily activated by polymerases, whereas if we have a cell without expression of the spike gene, maybe that's because it is actually wound up in the histone, therefore it's not accessible.